A standard modern car engine has a displacement of about 2 liters. This engine has 127, 36 cylinders, over 6,000 pounds, 5,000 horsepower from a single unit, more power than 3 Spitfires flying wingtip to wingtip. It was fully built, it was rigorously tested, and it never flew a single mission, not one. This is the Lycoming XR-7755, the largest piston aircraft engine America ever built. In 1943, the US Army Air Forces had a problem no existing engine could solve. Military planners wanted a bomber capable of carrying a heavy payload across 10,000 miles non-stop without refueling anywhere close to enemy territory. Every engine available was too small, too thirsty, or both. Multiple smaller engines strapped together added weight and complexity that ate into the very range they were trying to achieve. So Lycoming, a company that had never built anything close to this scale before, took on a contract to design something unprecedented, an engine that could outpower and out-endure anything flying in a single, self-contained unit. The design that came out of that contract barely looks like an engine. 4 rows of 9 cylinders arranged in a star, spaced 40 degrees apart, 36 cylinders total, feeding a massive 4-throw crankshaft inside a single central crankcase. And unlike almost every other big radial of the era, it wasn't air-cooled, it was liquid-cooled. A configuration nobody had attempted at this scale, because keeping coolant flowing evenly through 36 cylinders packed that tight is its own engineering nightmare. Then there's the camshafts, 9 of them, each with 2 separate cam lobe profiles built into the same shaft. One shaped for maximum takeoff power, one shaped for fuel-efficient cruising. A hydraulic mechanism could physically shift each camshaft sideways in flight, swapping which lobe profile drove the valves, changing the entire character of the engine mid-flight without touching a single bolt. Behind the engine sat a 2-speed, geared, contra-rotating propeller system. 2 propellers spinning in opposite directions of the same shaft, cancelling out the torque that would otherwise try to twist the aircraft sideways under full power. At just 6,000 pounds dry weight for 5,000 horsepower, its power to weight ratio beat almost anything else flying on pistons. Lycoming built 2 of these engines. Testing began in 1944 and dragged on for 4 more years through material shortages, propeller shipment delays, and a labor strike that held up for weeks. It wasn't until April 1948 that the engine finally completed a full 50-hour continuous run at its rated 5,000 horsepower. Local legend says a full test run rattled windows and shook cans of shells in a grocery store a half-mile from the factory. That detail is unverified folklore. But everyone who worked near the test cells agreed on one thing. Nothing built before it sounded or shook the ground quite like this. By 1948, the prototypes were finally running somewhat reliably, and by 1948, nobody in the newly formed US Air Force wanted them anymore. Jet engines had arrived years earlier, and they didn't just compete with piston engines, they made an entire category of engineering obsolete almost overnight. A jet needed a fraction of the moving parts, ran at altitudes and speeds no propeller could reach, and required nowhere near the maintenance of 36 liquid-cooled cylinders and 9 shifting camshafts. The program was finally cancelled in 1948. The most powerful piston aircraft engine ever built in the United States had no aircraft left that wanted it, and no war left to fly in. Only one of the two XR-7755 prototypes survives today. It sits in the Smithsonian's Udvar Hazy Center, fully restored, the largest and most powerful piston aircraft engine ever built in the United States. A title it still holds decades later because nobody ever needed to build anything bigger. It represents the absolute limit of what a piston could do, reached at the exact moment the entire industry stopped needing pistons at all.